So today we're going to do the periodic table tour. This actually should say periodic table tour. Before we dive into the periodic table, there's a couple of things that we definitely need to define. Some are things that you've already figured out just by doing the simulation. The first is the term atomic number. It is the number of protons in an element. It is the identity of an element. So the entire periodic table is arranged according to the number of protons within an element. So for instance, this whole number that is here, anytime something is element number 4 and has 4 protons, it must be beryllium. Anytime something has 7 protons, it must be nitrogen. 15 protons, it must be phosphorus. If its atomic number is 30, it must be zinc. So the identity of the element is determined by the number of protons, which is the same as the atomic number. The second number that we see a lot on periodic table is called the average atomic mass. Sometimes it's just referred to atomic mass. It is the average of all the common isotopes of an element. Now, while this one is always a whole number, this one is always a decimal number because it's a weighted average. And I should say that it is a weighted average. Now, what does weighted average means? It means all of them don't have the same weight. Very similar to your grades, where 50% of your grade has to do with classwork, and 10% has to do with student engagement, and 40% has to do with assessments. They're not all the same. So it's weighted according to how much of it really exists in the real world. Now, in order to talk about the word average atomic mass, let's flash back to the definition of an isotope. An isotope, please ignore the dog in the background. An isotope is all of the common or isotopes forms of an element. They have the same number of protons, same number of electrons, because atoms are neutrons, are neutral, but different number of neutrons. Different neutrons. So let me give you an example. There is one form of hydrogen that has one proton, and floating around the outside is one electron. Okay, and this is not drawn to scale. Then you have one form that has one proton, one neutron, and one electron. And another form that has one proton, two neutrons, and one electron. All three of these are hydrogen. This one is what we consider to be hydrogen 1. This one we consider to be hydrogen 2, and this one is hydrogen 3. But all of them are considered to be hydrogen because all of them have the exact same number of protons, and protons are the identity of the element. Now that we've defined what an element is and we've defined what isotopes are, this average atomic mass, this funny number that we find on the periodic table. So for hydrogen, it is it's 1.008. That number is 1, almost 1, because most of the hydrogen is hydrogen 1. Most of it is this one. But there's a little bit of this one. And because there's a little bit of this one and a little bit of this one, this number is not quite 1. It's always going to be a decimal number. It is never going to be a whole number. Let me give you another example. Carbon's number is 12.011. We know that most carbon is carbon 12 because this number rounds almost to 12. But there is some other isotopes that exist. We know that most of the oxygen is oxygen 16 because this number almost rounds to 16. However, the average atomic mass is 15.999, which tells you there are some isotopes of oxygen available that are a little bit below 16. There are also a couple a little bit bigger, but overall, 16 is the number. Now let's do some other things with this tour of the periodic table. The periodic table can be cut in half, sort of, not in a perfect half, by a stair-step line. This stair-step line starts between aluminum and boron and steps its way down. We consider everything on this side of the periodic table but hydrogen. So all of this stuff over here, we consider it to be metals. We consider everything on this side of the line just about to be nonmetals. Hydrogen is considered to be a nonmetal. It is the only nonmetal that is on the left side of the periodic table. Now, there are also some things that are on the line, and certain elements on the line have some characteristics like the metals and some characteristics like the nonmetals. And so I want to tell you which elements those are. The ones we consider to be metalloids or semimetals are this one, boron, silicon and germanium, arsenic and antimony, and tellurium and polonium. These guys have characteristics that are like both, so we consider them to be both. Now, aluminum is on the line, but as most of us have seen aluminum foil, we would never think to call it anything but a metal. All of its properties are very metal-like. Let's talk about what these properties are. What are the properties of metals? Metals all have very similar characteristics, and those characteristics can be figured out about anything on this side of the periodic table. Not just the elements that you think of as metals, but also the ones that you probably don't think of as metals. So let me give you an example. All of the metals are shiny. They also are mostly solids at room temp. There is one exception to that rule, and that's mercury. Okay. They have a luster to them. That means that they're not just shiny, but they have like that shimmery um, thing going on. They are good conductors of heat and electricity. They are ductile, which means you can make wires out of them. They also are malleable, which means flexible or bendable. Think like a paperclip. And remember, these are all the guys on the left side of the step. Okay. So these are guys all on the left side. Some examples, some examples of these elements are things like um, sodium. Sodium. Now, this is not the same as sodium chloride, which is a salt. Pure sodium is actually um, like butter, soft like butter, but it's silver. Okay, and it's actually explosive in water. Magnesium is another good example of a metal. Okay, magnesium. Magnesium. And then we have all those other metals that you can think of. So, like silver, gold, titanium, all of those metals as well. Lead. Let's put that down. And in case you were wondering, sodium and lead have funny abbreviations because it's based on the Latin. All right, properties of nonmetals. Nonmetals can be found on the right side of the periodic table. Okay, they tend to be dull, not shiny. Okay, they are poor conductors. Most are gases. I should add that first. Most are gases. But those that are not gases tend to be dull. They're poor conductors of heat and electricity. The solids are brittle. They won't bend. You can't make wires out of them. They'll just shatter. Okay. And the last group is semimetals, which are sometimes called metalloids. And again, those metalloids are on the stair step line, and they have a mixture of both. So let me give you an example. A good example is silicon. Silicon is on that stair step line. Symbol is Si. Okay. Um, and even though it is somewhat brittle, it actually is a great conductor of electricity, which and heat, which is why it is often used in computer chips. And Silicon Valley is a common word for something that for an area in California where lots and lots of computer technology has come from. All right, make sure that you go ahead and you write your 2 sentence summary and that you do your practice. Thanks.